Hello everyone, I am Devash Mode of class 10. Today I am here to revise the chapter of class 10 chemistry. The chapter's name is Chemical Reactions and Equations. And there is a very good thought by Martin H. Fisher on the beginning of the chapter, that is, facts are not science as the dictionary is not literature. So this was the opening statement of the class 10 science textbook. So let us begin with the first topic, that is chemical reaction. So what is chemical reaction? Chemical reaction is something that involves chemical change. We represent the chemical reactions in the form of chemical equations. And while writing, I will tell you the form of chemical equations first. So first on the left side, there the reactants are written, and if the number of reactants are more than one, plus sign is added between them. And after reactants, we put an arrow sign, that is called arrowhead, and then we proceed towards products, that is mentioned on the right side of arrowhead. The same things applies on the products, that is if there is more than one product, we add plus between them. So this was all about chemical reactions. Now the next topic in the book is, and there is also one example of chemical equations that we have been studying since 4 to 5 years. The same one, that is magnesium plus oxygen gives magnesium oxide. And also I forgot to tell you, in chemical equations we while writing any product or reactant's name, we mention its state also. That is, for in case of magnesium oxide, this magnesium is solid, oxygen is gas, and magnesium oxide, so on. So here we represent liquid as L, gas as G, and aqueous. This is a new term. Aqueous means if something is in solution in water. So we represent aqueous in the form of AQ. So the next one is writing chemical equations, that we have already discussed. And the second one is balancing chemical equations. We balance chemical equations by calculating the number of atoms of each element on the reactants and products. So what is balancing chemical equations? That is making the number of atoms of each element, that is the number of atoms in reactants should be equal to the number of atoms of the same element in the products. So we can balance the chemical equations or reactions by this way. And there is a specific method for balancing these chemical equations, that is called hidden trial method. And we balance these chemical reactions by adding certain coefficients. Going further, we discuss about types of chemical reactions. The first one is combination reaction. What is combination reaction? Combination reaction is a reaction which has two reactants, and those two reactants give a single product. For example, CaO, that is quicklime, plus S2O gives rise to CaOS2, that is slaked lime, plus heat. But heat and energy, like that, some byproducts will be there that need not to be considered as one of the products. And another example is burning of coal, that is C plus O2, CO gives CO2, and formation of water, 2H2O, 2H2 plus O2 gives 2H2O. Then burning of natural gas, CH4 plus 2O2 gives CO2 plus 2H2. And there is one important chemical reaction that I want to tell you, that is of chemical reaction of respiration. That is one of the most important chemical reaction given in this chapter. One is of respiration, one is of photosynthesis. This is of respiration. The reaction is C6H12O6, that is glucose, plus 6 O2 oxygen gives 6 CO2 carbon dioxide plus 6 S2 water plus energy. So this was all about combination reaction. Now we come to the second type of reaction, chemical reaction, that is called decomposition reaction. Decomposition reaction simply means that we have a single reactant and we are splitting it into several parts. For example, in the case of ferric sulfate FeSO4, when it is heated, it gives rise to ferric oxide Fe2O3 plus SO2 plus SO3. So here we have ferric sulfate on the reactant side, that is a single reactant, and after heating we get three products. So the definition of decomposition reaction is: a single reactant breaks down to give simple products. This is called decomposition reaction. You can I also wanted to mention that I won't be able to discuss all the reactions because it will take more time. So I will be briefing you about all the reactions and all of the necessary concepts. So this was all about decomposition reaction. Now let us go to displacement reaction, third type of reaction, chemical reaction, displacement reaction. Displacement reaction. So you consider, I will explain you with by taking the example of a chemical reaction. The chemical reaction is like this: Fe plus CuSO4. See, I will tell you in word form. Iron plus copper sulfate gives rise to iron sulfate plus copper. If you have observed what I have said, first I said iron plus copper sulfate, that is Fe plus CuSO4. Then it gives rise to FeSO4 plus Cu. This in this reaction, Fe was a single element in the reactant side, and there was another reactant called copper sulfate, that is CuSO4, and on the product Fe, it becomes FeSO4. That means the SO4 sulfate which was combined with Cu, copper, combines with iron in the displacement reaction, and the Cu becomes separate and independent. It becomes lonely. There are many tricks to understand displacement reaction also. In displacement reaction, we have I will tell you a trick. In this reaction, I told you earlier, only one polyatomic ion is displaced, and we should also always consider the relativity series while displacing these polyatomic ions from the reactants to products. Okay, you will understand this when I explain the double displacement reaction. So in double displacement reaction, there is a very important thing that is formed, that is called a precipitate. And there is one word, catalyst. What is catalyst? Catalyst is something that fastens a chemical reaction. And as I was talking about precipitate, let us go to precipitate. During the process of double displacement reaction, we see a white substance which is also insoluble in water. This insoluble substance formed is known as precipitate. Any reaction that involves precipitation is called a precipitation reaction. Usually the precipitation reaction are examples of double displacement reaction. Now let's go to I will tell you one example of double displacement reaction. That is Na2SO4 plus BaCl2 gives rise to BaSO4 plus 2Cl. Now by this I wanted to tell you the difference between displacement reaction and double displacement reaction. In displacement reaction, only one polyatomic ion is displaced from one element to another. But here, all the reactants, there are two reactants in this chemical reaction. So, in these two reactants, we have, for example, Na2SO4, we have SO4 plus BaCl2, we have Cl2. So that SO4 and Cl2 displaces, that means they overchange, and they combine, and SO4 combines with Ba, that is barium, and Cl2 combines with Na, that is sodium, which was earlier the Kriss-Krast method. Okay, so this was all about double displacement reaction. And then comes the important concept of oxidation. What is oxidation? For me, this concept was very difficult to understand. Honestly, I couldn't understand when I read about it for the first time, but I would try my best to make you understand this. So what is oxidation and reaction? Reduction. Oxidation occurs when there is intake of oxygen. There is intake of oxygen or loss of hydrogen. So when you see, if a compound is oxidized, so if you say a compound is oxidized, oxygen is added to it or hydrogen goes out of it. There can be two possible ways: oxygen is added to it or hydrogen is removed from it. And what is reduction? It is the other way around. Gain of oxygen or gain of hydrogen or loss of oxygen, that is reduction. And there is one more important point. In one chemical reaction, oxidation and reduction happen at the same time. That means if oxidation happens in a chemical reaction, reduction will always occur in the same reaction. Let's take an example. CuO, that is copper oxide, plus S2, when heated it gives to Cu plus S2. Here CuO is reduced to Cu and H2 is oxidized to S2. So here we can see that oxidation and reduction is happening simultaneously. And there are also many examples. For example, ZnO plus C gives rise to Zn plus CO. MnO2 plus 4Cl gives rise to MnCl2 plus 2S2 plus Cl2. Here I will tell you where the oxidization is happening. First of all I will tell you where the reduction is happening. In the reactant side there was MnO2, and in the product side it is showing MnCl2. So the O2 is reduced. So that means a kind of reduction has happened here. And HCl. In HCl we find HCl gets converted into 2S2, that is, it is being oxidized. Okay, so the last topic is of corrosion and transitivity, which are basically the effects of oxidation in everyday life. So what is corrosion? Corrosion can be defined as when a metal is attacked by substances around it such as moisture, acids, etc. It is said to corrode, and this process is called corrosion. Corrosion can be identified in many ways. In case of silver, a black coating will be formed on it, and on copper a green coating will be formed on it. And corrosion in iron has a very special name that we commonly know as rusting. And then rancidity. Now we had discussed about the corrosion of metals, that is degradation of metals. Now we discuss about the degradation of oils and fats. So what is rancidity? When fats and oils are oxidized, they become rancid and their smell and taste change. So you would have observed in some oily and fatty substances, when we keep it outside, its smell and taste change. That is that this phenomena is called rancidity. This was and also there is one example given in this textbook. This chips packet we eat, they are filled with the gases such as nitrogen to prevent the chips from being oxidized. So we should always remember the preventive steps of rancidity, because it is very essential for our food intake. If we leave anything that contains oil and fats, it will be it will become rancid and we won't be able to eat it. If we eat it, we won't be able to see the sunrise tomorrow. And for preventing this, there has to be many special preventive measures which has to be taken to prevent rancidity. And one of this was the flushing of gas in the chips packets, and in achars that we call pickles, we add vinegar and some other preservatives to prevent rancidity. This was all about this chapter. There are no other concepts remaining. The remaining part to study is the equations. You should memorize it and we can look forward for the exam. Thank you and have a nice day. I hope you understood all the concepts in a better way and will be able to score good marks in your upcoming exams. Thank you.